All right. About a little over a week ago, I showed a little sneak peek of what I call my semi-autonomous agent development architecture for Business Central. I think it could be shorter. I need to find an acronym for it. But I've set up a small test. I've experimented more with it since, where I can have AI-driven agents help me build a Business Central application. And I thought the best way to show how it works is to actually start building one. So in this little video, we will build the first the baseline of a new Business Central app, but have the agents build it for us. But first, let me just give a quick overview of how this works and what the underlying architecture and components are. So if we move to this slide, everything starts in GitHub. So the system is based on ALGO. So I have a clone of the ALGO for GitHub repo. And in that, I have added the necessary support for the agents to work. And the way that I've set it up is, of course, if you've seen agents work before, they work a lot off of Markdown files. So there's a set of Markdown files to set up how the agent should work. And then all of the orchestration handled is done through GitHub issues. So you will create a GitHub issue, assign it to an agent, and then what will pick that up and start the agents is first I have an N8N workflow. So N8N is a pretty good workflow orchestration package, and I'll show the complete workflow in a second. But it is pretty good at interfacing with GitHub. It can monitor my repos and see now there's a new issue that an agent needs to work on. And it will pick the most relevant issue to work on based on some rules. And then it assigns the issue to my agent manager. This is a little simplified. I actually have two different agent managers, one that handles if a task is more planning related, and another one if it's engineering related. But anyway, the agent manager takes the issue and routes it through the agent selector to the correct agent. At the moment, I have 5 different agents. As I said, they're sort of split into two different categories. The first two is Cliff and Fraser, who handle the planning related tasks. Agent Cliff, he is sort of the product owner, so he can get pretty high level tasks. He can himself suggest improvements to the current product or feature areas to work on. And the way he does it is he will break down a high level task into a set of feature areas or features that will then be assigned to Agent Fraser. So the output from the planning agents is also always new GitHub issues. So Agent Cliff will create a set of feature requests that will be assigned to Agent Fraser, who's my program manager, who will then later pick them up through the workflow here and break down the feature request into a set of engineering tasks that will also be created as GitHub issues that can be picked up by the workflow. So Agent Cliff always assigns to Agent Fraser. Agent Fraser will, based on the complexity of the task, assign to one of the 3 engineering agents. So there's 3 engineering agents, and if we start on the right here, Agent Daphne is my favorite agent. She runs on OpenAI Codex, and she can do heavy design, complicated tasks. You could actually even assign her a whole feature area, but at the moment I'm trying out a little more flexible model where the work is broken down by Fraser first, and then picked up by the agents. You don't have to go through the planning agents. I could assign a task to Daphne directly, and as I said, it can be pretty advanced and cross the whole application space. Agent Niles can do a lot of the same as Agent Daphne. Um, he runs on Cloud Code and can do the same type of design and architecture work. The reason I prefer Daphne at the moment is that the pricing is quite different. Niles tends to cost me quite a lot more to run than Daphne, and they're comparable in the output. Sometimes you can try both and see what gives you the best output. The last agent is cheaper. He's sort of free. He costs the power it costs me to run my workstation here. I don't have a super powerful workstation, but reasonable. If you have more GPU, I have 8 gigabytes of GPU and 64 gigabytes of RAM. And that's enough that I can run a stack with a local Oyama agent orchestrator. And I use the Qwen25 Coder 32B model, which through experiments with 6 or 7 different models is the one that I found is the best balance between quality and runtime. He'll still be slower and not as advanced, so he needs simpler tasks. But if the program manager has written a very detailed spec and it's just something that needs to be fixed in one file, for example, Sam can easily pick it up. All of the engineering agents, they produce output that's run by the agent manager through the AL compiler to verify that it builds. If it builds, the solution is committed to the shared agent branch that they work on. If it fails, and it's Agent Sam that was working on it, he can assign the task to one of the 2 senior engineers. At the moment, he will take this route to Agent Daphne. As I said, she's my preferred agent. And if Agent Sam has built something that fails, Agent Daphne then gets the build output with the build errors and the code that Sam wrote, and she can usually fix it or just redo the code herself and submit it again. And once it compiles, it gets committed to the branch. If one of the 2 senior agents here fail the build, it just gets stopped in an error state for human review, and my workflow at the moment pauses until the error has been resolved, because there could be dependencies in later work that needs the work from this task. So that's the workflow. I'll show more details when we build the actual application. So let's do that now. So now we are in GitHub, and I mentioned I have my app template here based on ALGO for GitHub, and I can use this as a template to create an agent enabled workspace. So I'll use this template, and we will create a test app that I will call Seat Filler. So the app that I'm going to build as a test is an event management and booking app. So we want to be able to create events and register people that book for that event. So I will create that. Okay. So what I get is all of the usual ALGO stuff. I'll not go through that here. You can do everything. You can set up the project however you want. I have a pretty simple setup with just one app file and a library project. an app project and a library project. But the stuff that gets added to support the agents, we can start here at the root. If you've done any agent work, especially on Claude, you know that Claude likes to read a claude.md file that has directions on how the agent should behave. And I have one of those as well. And this is actually where, if you discover anything that it does wrong, this is a good place to update it. I had one example actually where there was something about missing permission sets. There's also some naming rules that, object names can't be more than 30 characters and so on. Stuff like that you can update in the CloudMD file. It's a bit of a test to see where you put the instructions, whether it's in the CloudMD file that's shared across all agents, whether it's in one of the project-related markdown files that I'll show now, or in the agent instructions. There's different places to put it. So one thing that's added is a docs folder. And the docs folder has some markdown files, some that are used up front and some that are used during the work. And just go through them. So the architecture.md file, it defines the base architecture of the product. And there's actually some things that you need to replace there. The README file for the repo will mention what you change here. So let's just do that now that we have it open. There's the app name, which is the first one. And I will call this app, as I said, Seat Filler. So let's replace that. There's a namespace. It does use namespaces here, so I will call this it.seatfiller. Replace that, and I think there's a company name. I need to clean this up a bit because I think they're not all needed, but for now we'll just put them in. And commit that. So again, you can update the architecture.md if you change the structure of the project. This talks about, as I said, that you have application and library. Also has tests. As you'll see, I have not gotten to that yet, so it doesn't. The agents don't generate any test. That needs to be added as well. There's an engineering guide. To begin with, you don't have to change that. It also has a lot of instructions about how to build the AL code. It mentions all about the project structure and so on. And then there's object ranges.md. This one you might want to change. So each project, of course, should have an ID range. At the moment, the way I've set it up is you both have to change it in here in the Markdown documentation, and as you are used to in the app.json files. So this also has some namespaces, and I just change it to the one we chose. So it's going to be it.seatfiller. I'll leave the number ranges as they are here, but you could change those as well. All right. Then the last two markdown files, one is the product vision. It's empty at the moment. And of course, the idea is that here you put in what the product is supposed to do. And user guide is on the other hand of that. This is where the agents, as they build out the app, will update the user guide with the functionality that's been added. So you don't have to add anything to this one. The agents will do that. But a product vision we have to fill in. So let me just edit that. And I have prepared, and I will, in complete honesty, say that since this was an AI and agentic test, I actually had ChatGPT write the product vision as well. So I have one here ready to paste in. I won't do a lot to go through this, but it explains the event and booking management app, the primary functionality to create events, manage capacity, and handle bookings. Who are the users? What's the problem statement? We don't want to do manual booking and spreadsheets and so on. It has a short list of core concepts and um, a suggestion for what is the first phase, the MVP for the product, and what could be future features. There. So now we have the product vision in place. Those are all of the stuff that we need to change here at the high level in the repo. The rest we can do in the BC project itself. So let's do that. Just copy the GitHub URL here, and then we can clone the project locally. I have my projects folder that I use here, so I'll clone the seat filler app, and here there's a main folder where the ALGO project is, and I can open it in VS Code here. So here's the main workspace, and there's the usual stuff that we need to update here. So there's a library and an application section, and we need to update the app JSON. So we will call this seat filler libraries, like that. This is where we would update the ID ranges as well. Maybe you'd want a different GUID. I'll just leave it for now. And the similar app JSON here should reference the seat filler libraries, and our app will be called seat filler. There, say that. If you change the number ranges, you have to change them here as well as usual. Then there's launch.json files. I'll just put in one that points to my my sandbox. There. And we should be able to deploy this to the sandbox now. Let's just try, press F5. I just want to make sure the foundation is working before we let the agents loose. The project comes, as you can see, with a little sample here. We don't have to run that. This launches. That was the libraries. Let's check the main app. Okay. So now the app loads as well. And if we then finally just commit our changes here, we probably just have to the initial repo, and we need to sync there. So now we have a baseline, we have an app that works. Maybe before we get started with the agents, now we know the project builds, I'll just remove this sample page and the sample helper there. Removed sample. So now we have a clean project we can start working on. So let me exit here. The next steps for building the application will all be done here in GitHub. Everything works through GitHub issues, as I mentioned, and there's some support. There's actually a small PowerShell script that you can run to create them. I just did that. I didn't put it on the recording here, but the agents all work off of GitHub labels. You'll notice here that I have all of the 5 agents have a label. You could maybe set up something where you worked off GitHub users, but that I got into all sorts of things with licensing and so on that I didn't want to deal with. So I'm just using the labels to route to agents, and it works pretty neat, I think. So Agent Cliff, Agent Daphne, Agent Fraser, Agent Niles, and Agent Sammy, each has a label. The way that they communicate progress and so on is through a status label. So there's a status on hold, status error, and status complete. Status error, I mentioned earlier that when something a build fails, it'll be put in status error, and that'll actually hold my whole agent pipeline. But to get started, let's create the first issue. The repo comes with some templates that you can use. You don't have to. You can just create any issue. As long as it's assigned to an agent, they will pick it up. But I do have a design template, a feature template, and a fixed template. The idea is that the fixed template is for small, simple changes, stuff that you could assign to my free agent, Sam, for example. Feature, as it says, is a bit larger and has more details in it. And then there's the design template. Now, actually, as you'll see, the agents themselves create the issues. They don't actually use these templates, but something similar. So it's not always that this is just for the manually created issues. So let's create the first issue, and what we want is to ask our product owner to build the MVP for the product, right? So product owner is Agent Cliff, and we will ask him to create the minimal MVP scope for seat filler. And this one I also have a ready-made text for. Plan minimal MVP scope for seat filler. There's instructions in here to review the product vision that we wrote, break it into some planning tasks, and what the MVP scope should be, just event and booking registration, capacity tracking, and so on. And also what it should not include. So it's trying to create something simple to begin with. Let's create that. And it looks like this. And to get the agent to start working on it, as I mentioned, I just use labels. So we assign it to Agent Cliff. And we can look at the issues here. Oops. Actually didn't get it assigned. There. So now it's assigned to Agent Cliff, and he should pick it up in a short while. At the moment, the way my agent workflow runs is that it runs every 2 minutes. But while we wait, let's take a look at the N8 workflow that runs all of this. So it looks like this, and I will zoom in and show you the details of it. This is the beginning. I mentioned it runs every 2 minutes, so there's a schedule trigger that kicks it off. Then what it does, you could set it up different ways. At the beginning, I had notes here against GitHub where I had selected the specific repos I wanted to run it against. Now I made it so that it will just run against any repo in my organization. You can do different variations of that, and N8N is pretty good at it. For now, I loop over all of my repos, and it gets all of the repo issues. As I mentioned, this is actually where it's handled that if there's an error state in any of the repos, it'll halt the workflow. That's done in this node. But other than that, it loops over and gathers all of the issues. Then it uses some prioritization. It will always prioritize engineering tasks over planning tasks. So as long as there's some engineering work left, it'll do that before it does the next set of planning. Then it sorts, and the sort is just so that it runs old tasks before newer tasks. So after the sort, here we can see it all. After the sort, it picks one item, that's all this node does, and then it runs into the agent switch. And I don't know if it's too small. I can zoom in a little here. You'll see the 5 agents. So this switch will route to either Niles, Sam, Fraser, Daphne, or Cliff. And in this step, it can set some agent-specific variables. So if you want to tune them differently, you can control it with variables and set them here. The next step sets some shared variables for each of the agents. And then this switch at the end here just routes to the two different types of agent managers that I have. Either the engineering agents, they go here, or the 2 planning agents, they go here. This fires off a PowerShell script, and there's one for each of the 2 types of agents. Let's look back at our issue. Actually, you can see, I wanted to show that it started it, but it's already complete. So if Cliff has done his work, he should have created some planning issues. And now we can see here, the Cliff task is closed, so that'll be in here. And now it has created 5 planning tasks for Agent Fraser. So that's the next step, that the Fraser agent will pick up. Oops, and you can just see he did. So status started. And he will start doing planning. And what he will create is then engineering tasks based on the task that he got here. And the first thing he's asked to plan is the event data model. We can take a look at what it is. So this is what Cliff created. Define and implement the core event data model for seat filler, including the event table with all fields, name, description, date, blah, 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 blah. So this is what Cliff created for Fraser to work on. And you can see the agents, they actually add comments to the issues. So Fraser has told us he start working on the issue. The agents also log everything. So while he's working or when he's done, we can take a look at the logs. Show you. Here's all of the logs from the agents. And you can see the Cliff log here and the Fraser log. He's just started working. So if we open the Cliff log, here it is. He runs through pretty detailed what he did, what files he created, and so on. So you can also check. It's good if something goes wrong. It's a nice way to check it in there. One thing that the planning agents do is that they create planning documentation. So if we look at the repo now in the docs folder, you'll see that there's a planning folder now. It wasn't there before. And if we go to that, there's the event booking MVP feature area. So this was done by Cliff, and he's describing what the event booking MVP feature area is. And then he broke it down into tasks for Fraser. And there's the event data model, the booking data model. And these are all markdown files describing the work. Now as Fraser does his work, he will write markdown files as well. So it'll build up all of the engineering documentation as it goes along. They will also update, probably hasn't done that yet. Oops, you see, we can see that first. Fraser actually has already done some of his work. So he's done some design. He's worked on the event data model, and he's created the first tasks. You can see here, create event data table markdown. And here we can see the design document that he's made. There's acceptance criteria, and there's even an almost complete design ready to go. What I just wanted to say here, the user guide. No, they haven't updated that yet, but they should. So we saw that Fraser had started his work. So if we go to the issues, you can see that Fraser has taken what was planning task 1.1 and has created, at the moment, 2 engineering tasks, 1.1.1, create event table. And Agent Sam has been assigned to complete it. So I mentioned Agent Sam is my local event running on Oyama on my workstation. So if you hear a little noise from my desk in a moment, it's because my workstation spins up. It is pretty well loaded when that agent runs, but it tends to work fine. If we open the issue here, you'll see that we can first of all see that the label has been added, that it has started the work. We can see the task here. It's the same as the markdown file that you saw in the repo, and we can see that Agent Sam has said he's started working on the issue. So the way that the workflow I showed works is, I mentioned that as long as there's engineering tasks, it'll start working on the engineering tasks first. So now it'll complete the engineering tasks for the first feature plan that we made, those 2. And then after that, Fraser should pick up and start planning for the next feature area as well. So I will just pause the recording, and I'll come back and we can see what Agent Sam has done, because as I said, it can take like 10 minutes or so for him to complete a task. So the agents are still working. I just wanted to show one of the examples that I mentioned before. You saw before that Agent Sam had started working on this create event table. I would actually have thought he would be able to do that, but apparently not. So he has automatically routed the task to Agent Daphne. So if we look at the event here, we'll see here at the bottom that Agent Sam started the work, but he was not able to complete it. There was a compilation error, actually a lot of syntax errors. So he has done something wrong here, and he automatically assigned it to Agent Daphne, who will pick it up, or already has picked it up, and will start working on the issue. So let's hope that she will be able to resolve it. Oh, she actually already did. So we can open it again. You see Agent Daphne has completed the work. This is pretty typical that Sam will fail sometimes. I still let him start it because he's free, as I said. But if he can't do it, he will assign it to one of the other agents. So now, let's just refresh here. Now Sam is working on the second engineering task for this first task. So we'll leave him to it again, and I'll get back later with the result. Some time has passed now. You can, if you've been watching the clock in the bottom of my screen here, you can see a couple hours passed, and I'm checking back on the agents. I actually had to stop it for a while because I made a little robustness tweak to the N8N workflow to make sure that it should never start 2 tasks at once, and it actually did that by accident. So I added an additional check. At some point, it might be interesting to have them run in parallel, but it would mean that you have to separate the tasks and the agents out better than I have at the moment. They need to be sequential for it to work right now. But you'll see that it's working through the first task fine here. If I just remove here, we can look at all of the created issues. scroll down. Remember, we started by asking it to create a minimal MVP scope. Agent Cliff did that, and he created 5 planning tasks in total for Agent Fraser. And we can see that 3 of them are complete, the event data model, the booking data model, and now it's working on 1.3. Well, Fraser has planned the event UI, and the last 2 planning tasks are still open. The engineering tasks, you can see it's a nice mix between Daphne and Sam, who's been able to complete quite a few of them, so that's nice. It's always better when he can do it, but he has assigned it on to Daphne in some cases. And he's at the moment Daphne is working on 133 create event card page, and there's 3 more engineering tasks left, and then after that, Fraser will break down the last 2 planning tasks, and then we're done with this batch, day 1, for my seat filler app, and then we'll take a look at what the agents have built when they're done, and see if we can run it and make a plan for the next iteration, which I'll do in the next video. So I'll leave the agents to themselves for a little while longer, and then we'll check in on them again in maybe a couple of hours. So the agents have completed all the tasks now. It ended up being 33 GitHub issues. I actually had to make a small change to the local agent build engine because Fraser, I mentioned that I didn't support tests yet, but he actually asked Daphne to create a capacity enforcement test for the capacity enforcement logic. So it has created a test and put it in the test application, but my local agent build ignored that or didn't include it in the build in the right way, so it failed. So I had to fix that, but now it works. So it's built that and it's included the test. So the way that it works now is that all of the initial work is done. There's an agent nightly branch now, and I can open that in VS Code. So I have the agent nightly branch here, and I can see all of the code that it has built. You can see there's a booking section and an events section, and I can run this with a file and deploy it to my sandbox and make sure that it looks okay. Here it is. And now I should have events. So there's an events list form now. I can create new events, see the related bookings, if there were any. And there should be a booking form as well. Oops. Maybe there's a bug. Let's just refresh. Booking list. But there's no data, and it's a little difficult to work with like this. So I actually think that I'd like first to do one more iteration and improve the user experience a little and add in some test data. But before we do that, I'll just complete this version of the agent run and pull this into main. And just merge it in straight away here. There. So now all of our initial run is on the main branch. The agents updated, as I said, some of the markdown files as well. We can look at object ranges, and you'll see that the objects that it's created, it has put in the IDs that it used here and which objects and object types it was. The user guide has been updated. I think this first section should be rewritten. It's not so easy to read, as you can see, but we'll ask the agents to do that as well. But the core concepts are described: the event list, event card, bookings, viewing bookings for an event, and so on, and the capacity enforcement logic that it has built. But like I said, to make it a little easier to work with, I will add one more task and ask Cliff to do this for me. So this is just to improve sort of the getting started experience. So we'll say make the first use easier. And what I will ask him to do is, oops, yeah. So we'll tell Cliff to make sure we have a better first use experience of the seat filler app. I'd like a role center and a profile I can use, and I'd like a load sample data function where I can have some data to play around with. And then I would like that to be used in a getting started tutorial in the user guide. So let's create this task as well. I'll just assign it to Cliff immediately. Create. There. And we will let him do that work, and then I'll get back and we can take another look at the application. So some time has passed. I've been doing some other things, picking my wife up in the airport and getting some sleep while my agents have been working. So let's see how far they are. So there's no open issues. So let's see how they did on the new task that I created. That was this one, make the first user experience of seat filler better. And Agent Cliff has been working on that. He's assigned Agent Fraser to create a plan, to do a role center and a profile, and to load some sample data. They're also updating the user guide, which is pretty cool. So everything is completed. Sam has done a few of the tasks, but we can see that actually Daphne has had to do most of it. So we can take a look at, first of all, the user guide should have been updated. So if we scroll down, there's the core concepts: managing events, event card, viewing bookings, managing bookings, capacity enforcement, and available seats. I was expecting, oh, that's actually because I'm not looking at the agent's work, so we should just switch to the agent branch. We can actually see the differences. So we can see the role center has been added, and viewing bookings is the same, managing bookings, and we have a section down here that talks about loading sample data. And there's a getting started tutorial now that uses that sample data to guide users through getting started with the product. So that's pretty cool. So let's try to run this. I'll open the workspace and make sure that I am on the right branch. The agent branch, I am. And just press F5 to go. There. I should set up my role. Oh yeah, it's already selected. I actually tried this before I started the recording. So seat filler manager. So if I go to the role center, I now have seat filler information here. I can go to events. I can go to the booking list, and I have some queues here that tells me some information about it. But now I have the load sample data. So let's try and do that. Sample data loaded successfully. Just refresh the role center. Now I have 5 upcoming events and 51 total bookings. So now I can start to play around with it. I can see the sample data has loaded. I can take in Excel for beginners class. Looks popular. There's 7 booked seats. I can actually see there's a bug somewhere because the available seats shows 0 for all of the rows. I think there was the one test that the system did was actually something about the capacity handling. So it could be interesting actually to run that test. I think we'll try to do that in the next video when we plan the next iteration of the system here. I can open the booking. I can go to the event, and I can go to bookings for the event, see the bookings. I can also see it's prepared that I can actually link it to an existing customer in the system. But pretty cool. I should find out about the bug here, and as I said, then we will go further and see what the next steps could be for the app. So that's the end of my first agent built app demo. I think one more thing I'll take a look at before we end it complete is the object map and see if that's been updated. Yeah, we can see we even got the role center, the queue, the sample data, and so on included here. And the capacity enforcement test, I'll have to take a look at that and why the capacity wasn't calculated correctly. So that's the tasks for the next round. All right, that's it for video 1. I'll keep building the app, and I'll do recordings of where it goes, and then we'll see where it ends, how far we can get. There's not that much real logic now. We also need to look at it when it starts to build database code, if it does it correctly, if it can do commits and loggings and different read strategies and so on. So that'll be interesting. So thanks for now for this video.